Hello, I'm glad you could join us today. I'm Danielle Walker, Senior Reporter at SE Magazine, and I'd like to welcome you to today's webcast entitled Applying Automation and Analytics to Threat Visibility, Verification, and Removal. This session is sponsored by Hexis Cyber Solutions. Our speaker today, Chris Carlson, is Hexis Senior Director of Product Management for the HawkEye G Threat Removal platform. Chris is responsible for product strategy, product definition, and roadmap and technical partnerships at the company. In this webcast, Chris will explore how external threat actors are using innovation and automation to stay ahead of traditional security defenses. He'll also offer ways to use automation and analytics for visibility and removal of threats before compromise occurs. With that, I will hand things over to Chris. Welcome.
Great, thanks very much. Hi, this is Chris Carlson. So I run product management for Hexis, and I'm thrilled to be here today to talk about how you can use automation and analytics for threat verification and removal in your network. So for today, I want to start with around the modern problem of security defenses. You know, for those of you on the phone, you probably have a lot of technology in place at the perimeter, maybe on the endpoint, maybe in your security monitoring system, but that's not really solving some of the problems, and I'll talk about why. Right? I'll talk about how modern threat actors and attackers are able to use evasion techniques to get by those defenses. And then I'll talk about around automation. So the theme that we use at Hexis is how can we give a defender's advantage? How can we give you an advantage in today's security ecosystem to use automation to detect and verify and respond to threats before they cause compromise or breach in your environment? And we do that at Hexis through a platform that we call HawkEye G. We have a new version that we released a couple months ago, around 3.0, and we'll talk about how you need endpoint detection, network detection, analytics to do automated response to give you that defender's advantage. We're thrilled to announce that we have new joint technology integrations with Palo Alto and FireEye, but also the ability to tie into your existing security event monitoring infrastructure and then how to register for a demo. So that's what we'll talk about today, and we'll go right into it. So attackers are counting on two things. They're counting on that your prevention can never be 100% accurate. You know, it is an arms race with signatures. It's an arms race with zero-day attacks, and they know that, and they're trying to use innovation and automation to get around prevention mechanisms. So they account for that to actually give compromise and infiltrate your endpoints, primarily your end-user machines, who can be targeted for spear phishing attacks or watering hole attacks or malvertising, which is infected advertisements. And once they get a foothold into one endpoint, then they have the time to operate. They have the time to do reconnaissance. They have the time to laterally move throughout the environment. They remove their malware that used for the delivery mechanism, and then they can go and live off the land using native Windows services to go after your high-value assets. And because of that, enterprises with limited detection capabilities either don't detect these information or they can't detect it fast enough for the threat actor to actually move throughout your network. And that leads to data breach or loss or maybe even sabotage. So prevention can never be accurate, and the time it takes to detect, if at all, gives them time to operate in their area. So these are the tactics that attackers are focusing on. From the Verizon Data Breach Report, global report on disclosed public breaches, over 85% of compromise took days or less to breach the organization. Now, Verizon Data Breach Report used the term days or less. Actually, 75% took minutes or less to breach the organization. But unfortunately, discovery takes days or more, and 80% of all compromises took weeks or months to detect. So that speaks to the level of detection that enterprises have. That speaks to the shortage of manpower to actually to detect these things and find where the root cause is. And unfortunately, most of the detection mechanisms are done through external third parties. If you take credit cards, it's Brian Krebs or the FBI or some other external entity like your Visa or MasterCard brand that has told you that you have been breached for credit cards. So it takes days or less to breach, it takes weeks or months to detect, and then that is that big time gap that external threat actors rely on. So why are attacks working? So they're working because they're more targeted now. They're targeting certain users. They can go through LinkedIn or social media profiles. They're targeting certain exploits and certain operating systems. They are no longer trying to do a broad attack, but they're targeting certain things of Java. They're targeting certain things of PDF readers. Here's a screenshot from the Black Hole Exploit Kit. And this is the exploit kit that you can buy on the dark web for as little as $50. And you can see that this actually is in Russian. And from here, you can target and set the exploit to go after certain versions of the browser, certain operating systems, and even certain helper applications like Java or PDF or these type of things. So it's very easy to create an exploit and a payload to target these things using an off-the-shelf application. So the bad guys are using innovation and automation to accelerate how they can create exploits and attack you. The second thing is that they have built-in evasion techniques. So once again, in this Black Hole Exploit Kit, they have an integrated scanner to a third-party service that will verify if that exploit has been detected by antivirus engines. So very quickly, in this exploit kit, I can log in, create an account, save it against the Scan for You antivirus scanner, and then you can see that this one exploit, it can be detected by 15 out of 33 AV engines. Now, if I know that you're running Bitdefender and it doesn't cover it, then I can just attack you now. But if I want to have a wider coverage, then I can actually change the code, recompile, change a bit, have a different hash, retest, and there's 0% detection that I can attack. So the mechanisms to evade antivirus is not trivial, and it's baked into exploit kits. That's why antivirus, has such a bad coverage, even for known applications. So the next approach that enterprises have been doing in the past couple of years is going towards sandboxing. And there's a lot of enterprises that feel that sandboxing is the best method against advanced persistent threats or unknown variants. And I would actually 100% agree a couple of years ago. What's happening now is the innovation from the bad guys is trying to evade sandboxes. So Bloor Research out of Europe did a study at the end of last year on, they interviewed customers who use sandbox technology, and they asked them what the effectiveness is of their sandboxing technology. 56% of the study said that sandboxing has missed malware infections. 52% says that it's difficult to manage. And in some regard, it could be for the amount of false positives or ghost alerts that gives up. A lot of the sandboxing vendors have old operating systems and unpatched applications. They do that so they can have a high number of detonated malware in their sandboxes. Unfortunately, the endpoint doesn't run that old version of Adobe or that old version of Java, so the endpoint isn't infected. They're not infected. So what that means is the enterprise is chasing these ghost alerts or these false alerts that don't really lead to an infection, and that's where the next thing comes from, negatively affects the customer experience in that area. 39% said it's highly effective at identifying malware. If this study was done a couple years ago, it would be a lot higher, but that is trending down. Some technical reasons around sandbox evasion is that it's an arms race. Once again, it's the bad guys innovating faster than the good guys. But a sandbox can't process complex dialogues. So maybe the malware prompts the user to do a CAPTCHA or do a math problem, 2 + 5 = 7. And once that happens, then they can launch their malware. A sandbox tried to speed the clock up. A sandbox tries to take, an hour of analysis down into 5 minutes. It speeds the clock up. Well, malware can detect those clock changes, right? Sandbox doesn't persist between reboots. Well, maybe the malware persists but only starts on reboot. Sandbox only does a certain number of human actions. Well, maybe the malware waits for other user behavior, connects to Wi-Fi, does a Google search, sends 5 emails. And there's a lot of innovation happening in sandboxing as well through some new vendors and new players in the space that overcome some of these. But once again, if the sandbox is at the perimeter and the user is actually remote or they're off-net or it's a social engineering approach, that's something which, may be not detected by a perimeter sandbox technology. So, a little bit cheeky in terms of this math equation, but with targeted attacks plus antivirus evasion plus sandbox evasion, then that equals that 100% compromise potential. So, the FBI director said that there's two types of companies, those have been breached and those don't know it. And I think that today, today's security operators know that there is something happening in their environment. And the prevention technologies, which they've done, unfortunately, hasn't really helped them. And that's why Gartner, that's why Gartner Group, the #1 analyst firm where top enterprises, CIOs and CISOs talk to, they're recommending to rebalance purchasing. They're recommending that you spent a lot on reducing threats at the perimeter. You spent a lot on reducing vulnerabilities through patch management and vulnerability scanning. Now it's time to reduce the consequence as part of the risk equation. So not enough spent on detection and response technology. Now, of course, we're saying that at Hexis because we have such a platform, but we also use automation to accelerate that at enterprise scale. So if today's external threat actor, whether it is a nation state, organized crime, a hacktivist, or even commodity malware, is banking on the fact that enterprises AV doesn't work, that network perimeter is easy to evade and it's blocking. They're generating a tremendous amount of events and false positives to review. If you have a SIEM and you're getting 1,000 alerts per day in your SIEM, you need 20 or 30 people just to look at each one. So when you stop looking at them, that's where the actual threat comes in. And then on top of that is, you security guys, you are spread thin. You have to deal with network events. You have to deal with endpoint events. If you have PCI compliance, you have to do audit findings 3 times a year or twice a year. There's more than enough work for security staff today. So how are you able to respond fast enough to things that matter? And that is why the threat actor is counting on that the enterprise is being blind to the breach. So the Verizon data breach report, the average time to remove threats is 240 days. The average cost is, a large number, $11 million. It's very quickly to compromise and data exfil. All these are numbers that you can't solve by throwing people at it. So you need to solve it by putting good technology, workflow, processes, and ultimately automation. So what we've done at Hexis Cyber Solutions and HawkEye G is create a platform to give you a defender's advantage. So on the detection side, our end-to-end platform has real-time endpoint agents that run on the endpoint. We do network edge detection to look for outbound command and control systems. And we also have opened up to a third-party ecosystem, not only bringing in threat alerts, but also sending out our indicators of compromise, our indicators of activity, our incidents into your security event monitoring system. This allows you, from an automated point of view, to have the system validate network alerts, have the system tell you exactly what process is sending that alert or that network event, what file is bad on the system, what registry key is doing that persistence. So we use automation and analytics to do all the verification. So it's very easy from a human manual action to quickly verify and respond, but it also gives you a high confidence for automation. So if you want to turn on automation, we have an increasing threat score. At the highest level threat score is 8 out of 10. We confirm 3 different ways that that is a bad threat. The mid-level scores, 6 and 7, we confirm 2 different ways that it's a bad threat. And then we give you other areas to research on your own. So we give you the confidence and the verification to use automation in your environment. So from a platform point of view, the HawkEye G has 3 major components. The first one is the HawkEye G Manager. So that is a server appliance, and it's preloaded with our policy manager, with our host sensor manager, with our threat analytics, our event data warehouse, our reporting system, and that manages the host sensor deployment for the endpoint, and it manages the network sensor hardware. So the host sensor is a lightweight agent for Windows platforms. It uses less than 1% CPU on the machine, so it's almost can't even detect that it's operating, less than 25 mega RAM, and less than 1 kilobyte per second of network usage to send information to the HawkEye G Manager. I'll talk about more of the network sensor in the next couple slides. The host sensor, rather. The network sensor is a set of hardware appliances that scale from 40 megabit for a remote office all the way to 1 gigabit or 10 gigabit line rates for data centers. And this deployment is meant to be at the internet edge, and it monitors for outbound traffic, outbound to command and control infrastructure, outbound traffic where infected hosts are requesting second stage exploits. So the endpoint gets infected and requests for a second stage exploit or a second stage download, and we monitor for that. And they all work in tandem to give you an endpoint and a network correlated visibility that's all managed by the HawkEye G Manager. So in a networking deployment, the HawkEye G network sensor, in these two diagrams here, it can be deployed in span mode. So you can deploy it off to the side and get full visibility of the network traffic going back and forth. Or it can be deployed in inline mode. If it's deployed in inline mode, you get all the same visibility, but you also have the ability to do two different things. You can get the ability to inline blocking, so you can prevent the ability to have infected hosts call out to a command and control infrastructure. We also have the ability to reroute that stream into a bot trap technology that we have deployed in HawkEye G, and that bot trap can actually interrogate the traffic coming from the endpoint so we can get some more information on that endpoint. So that way you get full flexibility if you want to deploy the network sensor in span mode for visibility or inline mode for inline blocking and redirection. The endpoint agent gets deployed on all of your Windows hosts, and the HawkEye G Manager is the server appliance that is deployed in your network and in your data center. So moving on to the host sensor. So we did a big update for HawkEye G3 that came out in March. And a lot of the focus was around the endpoint itself to give broad detection vectors and additional use cases beyond malware detection. So first on the malware detection side, the system has the ability to do signature detection. So yeah, maybe I talked what's bad about signatures in the past couple slides, but signature detection is an easy way to verify, high volume, important threats to offload the processing from our host heuristics. And we use those in concert so we give a higher fidelity of detection without impacting load on the endpoint. So our host heuristics is the ability to find malware on the endpoint without signatures. So we use a combination of static and dynamic detection around behavioral and anomaly analytics. We have 174 different analytics, and that lets the endpoint detect zero-day, unknown variants, and also evasion techniques from malware. So that combination of detecting the known or detecting the unknown or the zero-day is part of our endpoint capability. On the right-hand side, what we've done with our version 3 is create a real-time eventing endpoint agent in our host sensor. So the host sensor monitors for events of interest in real time and then uploads them to the HawkEye G Manager for processing. So for example, we monitor file create events for certain files like DLLs and binaries with PE headers. We look for real-time file modification events, real-time file delete events. We look for process execution and module loading and process termination. We also look for registry changes. So a new registry key, a changed value that points to a persistent point for a piece of malware. And we also identify network connections. And we real-time event that out up into our HawkEye G Manager. The end-to-end time between detection and publishing is less than 30 seconds. On average, it's about 12 seconds to push this information up in real time. So that gives you real-time visibility of all your endpoints from the HawkEye G Manager. And what we do is we keep a baseline of every host on the HawkEye G Manager. So whether the host is online and eventing or the host is now offline, we have an up-to-date snapshot of what that baseline was for that host. So that allows you to do new use cases beyond malware detection and removal. You can do ad hoc investigation. So if you have a threat intelligence provider, or you read something on a threat sharing forum, or you have some colleagues, in a peer company, if you work for a bank, if they say, here are some indicators or some observables that we've found. You can come into the HawkEye G platform, you can put in those MD5 file hashes or those URLs or those IPs, and instantaneously across all of your hosts, whether they're online or offline, you can see how many endpoints have those indicators. So that lets you do ad hoc investigation, and that to support things like malware hunting, or verification of infection spread, or maybe even to verify that users are running software that's not approved. So that real-time baseline gives you that up-to-date snapshot for hosts that are offline or online. The real-time eventing also detects when files delete. And that's important because a lot of detection systems only tell you new information. This is new, this is new, this is new. So your SIEM, your event monitoring system, now fills up with all these alerts, and you have to dispose of every single one of them. What we do with the auto external remediation is if the real-time host sensor detects that a malware object, a file, is deleted, then we mark it as this is now remediated from the platform, from the endpoint. So there's some malware that actually downloads, drops, and when it executes and creates a second stage, it deletes its original payload. It deletes its original file. If you detect that in any other technology, it fills up your alerting system with all these files that no longer exist on the endpoint. We will detect with HawkEye G that the file has deleted itself, and we reduce that as an indicator in the overall device itself. And that gives you a very powerful view of actually what's happening on the endpoint right now, not just the history. So we give you a real-time view. So when you look at our product interface, so it's a web-based browser, role-based admin, the dashboard, you can log in and get a snapshot of your current infection status, your current remediation status, how much is remediated through automation policies, how much is remediated through machine-guided or human policies, how much is open, top infected hosts, how many endpoints you have deployed. You get a very easy snapshot of what the system is in your current environment. The incidents page, and we use STIX terminology to define the objects in our product: events, observables, indicators, and incidents. The incidents page in HawkEye G is prioritized and aggregated by threat score. So we developed a threat score model as part of a new function that we call ThreatSync. ThreatSync normalizes and fuses endpoint events and observables and indicators, network events and indicators, and third-party events into an aggregated device score based on what the threat actor is doing on the platform. I'll talk about those in the next couple slides, but this lets you easily and quickly find the most important system, prioritize its response, do some quick verification that you verify what HawkEye G found is exactly what's happening, and then take a immediate manual action. In automated mode, the system will tell you what it's performed. In machine-guided or human-operated mode, the system will tell you what you need to do. So if we see a malicious running process and you don't have automation turned on, the system will say, you can execute this kill process command. If it is a bad file or it's in a registry path, the system can tell you, we recommend that you quarantine the file, prevent it from executing in the future, remove it from the registry. You have the ability to use automation to take bulk actions. You can kill hundreds of processes. You can quarantine thousands of files across your entire network infrastructure. We have a large customer that deployed version 3. They have 2,000 host sensors deployed, and of the 2,000 host sensors, 36% over 650 endpoints are infected. They run a commercial-grade antivirus. They run a commercial-grade anti-malware, and we still detected an additional 650 hosts being infected. So one, that speaks to our ability to do detection. But how do you remediate or fix manually 650 hosts? In HawkEye G, you can set up your policy, do your bulk actions, and clean them all off all in one mouse click. So you get that power of automation. The last slide here is, hopefully you can see the resolution, is an indicator, an incident where we got a FireEye malware object, a FireEye sandboxing object. So I talked about that sandboxing can be evaded as one, but also may not be accurate representation of your endpoint. It may detonate in the sandbox, but the endpoint was not infected. In this case, we got the sandbox alert from FireEye. We correlated with the endpoint sensor, and we found that 4 of the malware objects were resident on that endpoint. And with automation, we automatically kill those processes and quarantine those files. And you can see that now it's moved down to a blue score of 1, which is a remediated indicator. So now, if you're a FireEye customer or with Palo Alto using Wildfire, and I'll talk about the supported technology vendors, if you get sandbox alerts that are ingested directly in the HawkEye G, we'll confirm if they exist on the endpoint, and we'll automatically remove them if you have policies set up. So you don't have to verify each one. You don't have to look at the 10,000 alerts that come in. The system will find the 1 or 2 that is truly on the endpoint and then remediate those based on your policy. So that leads to what we talk about, this new technology in HawkEye G that we call ThreatSync. And in order to do that endpoint and network correlation, we have a set of capabilities to normalize alerts into a common alert model, and we do that through our threat fusion. We take all that threat fusion and we normalize end user endpoint activity and indicators, network indicator and activities, third-party network activity and indicators. We fuse it together into a common model, and we bring it into our threat analytics. And the threat analytics calculates that threat score. For us at Hexis, our model on the threat score is based on what the threat actor is doing on the endpoint. It's not based on the severity of the malware itself. Because one mechanism that the threat actors are able to evade is that they're taking a very lightweight, very benign, maybe even a low-ranked, an existing, known, low-ranked piece of malware, and they use that as the exploit vehicle and as the delivery vehicle to download a second stage. So if you have 1,000 or 5,000 low-ranked alerts, you're never going to get to them because you're looking at your high ones. But the external threat actor has evaded by actually having a low-ranked system and has landed and implanted onto that endpoint. For us, we don't care so much about the severity of the malware. We care about what the threat actor is doing on the endpoint. Did they drop malware? Did they infect the system? Did they implant for persistent? Are they executing? Are they doing remote control? So that's why we do that in terms of threat analytics. So I'm thrilled to announce in version 3 of HawkEye G, we have built-in integration with Palo Alto networks, both their firewall and Wildfire, and also FireEye NX, the web appliance. You configure those platforms to send their output, their threat alerts directly into HawkEye G. We take them in, we correlate, we create threat scores, and then we drive any policy actions based on automation or other policies set up. But if you don't have Palo Alto or FireEye, we can still integrate with your existing infrastructure. So via common event format and syslog, we will push out everything the platform has found. We'll push out indicators. We'll push out aggregated incidents. We'll push out threat scores. We'll push out the success of a remediation action done by HawkEye G and the resultant threat score. We'll push that into your SIEM or your Splunk or whatever you use for your security operations. So if you have Cisco or SourceFire or Checkpoint, any IDS or web proxy, and it's going to your SIEM, HawkEye G will push out indicators and infections and incidents into your SIEM as well. We would send the same threat scores. You can look at your SIEM. You can say, oh, HawkEye G found something, and my IDS found something. Let me pivot back into the GUI, which I just showed you, on HawkEye G, do one last step verification, and then click manual countermeasures if you don't have automation set up. So part of the automation is not just on the removal, but the automation is also for detection, verification, and correlation. So if you have Palo Alto and FireEye direct integration, if you don't have those technologies, we integrate through your security ecosystem through common event format, syslogging, and the ability to confirm host infections, and then come back to the interface. So from a data flow diagram, so I talked about the HawkEye G network sensor that sits at your internet edge. It's detecting outbound connections from infected hosts, outbound connections to command and control infrastructure, outbound connections to download second stage, outbound connections for dynamically generated addresses, or single flux or fast flux DNS. So we detect all that information and we send those as indicators into our ThreatSync fusion. The endpoint, the HawkEye G host sensor, the real-time eventing, file creates, file drops from an infected process, process calls, modules loaded, registry key changes, network connections. We push all that into our ThreatSync model as well. We have a threat feed that comes from Hexis, and we also have a real-time cloud intelligence service that gets further verification through our ThreatSync model. We do fusion and analytics. We create indicator scoring and device scores, which I showed you in the screenshots. And then if policy management is set up, then we execute countermeasures, kill a process, quarantine a file, remove the registry executable, block a command and control port in those access. So the countermeasures can be executed manually, but that's what that data flow happens. With syslog, then we send all that information out, indicators, incidents, new scores, score changes into your SIEM or into your Splunk infrastructure so you can confirm what we see with your third-party devices. So you don't have to integrate it exactly. You can see it here. Now, in 3.0 for HawkEye G, if you do have Palo Alto Networks Firewall, Wildfire, or FireEye NX, we can take those objects in directly into our ThreatSync model, correlate those with what we've seen on the endpoint, execute countermeasures and remediation automatically through the platform or machine guided. So that is the data flow there. So I talked about the threat scoring model with ThreatSync, right? And our premise around HawkEye G is it's important to know, and we understand how the external threat actor exploits the machine, how they take control of it, and they use it as a staging area to do reconnaissance or lateral movements into other high-value assets. But in order to take control of the machine, they need to do a couple things. They need to exploit. They need to land, first stage or second stage. They need to implant and persist to survive reboots. They might need to evade, right? The process needs to execute. It needs to communicate outbound to a command and control server, and ultimately they take control of that. All of those are indicators of activity, not just indicators of compromise, but indicators of activity that we monitor in real time using our real-time host event, and we use our threat analytics to give the increasing threat score of the threat actor doing their work on the endpoint. So number one, through our file create and our file process detection, our file create and our process detection, we can see if anything landed or starts to execute on the endpoint. We will look to see if that's a 0-day or unknown variant using our host heuristics. We will look to see if our network sensor has found network indicators and it's coming from something non-confirmed on the endpoint. As we confirm it through our cloud malware verification service, as we can confirm it through our threat feed, as we confirm it through third-party ecosystem, that raises the threat score to an 8. We determine if it's dormant or if it's persistent. If it's executing, we raise it to a 9. If it's communicating out, we raise it to a 10. So that's very important because you can apply automation policies at each threat score level on a set of machines in your environment. So maybe one set of machines, you're only going to do automation at a score 9 or 10. Actively running malware, actively talking out. Maybe on another set of machines, you just want to whack all the stuff as soon as it drops. I'm going to whack 5s and higher. I'm going to whack 3s and higher. So you have the ability to fine-grain your automated response based on the policy management, based on the threat actor actively doing things on the endpoint. So remember how I talked about that you can do auto remediation, that our real-time eventing does that? That lines up into our threat management lifecycle. So once again, most detection is always new indicators, new alerts, new indicators. We actually will tell you when something has been remediated. When an individual indicator has been remediated, the process is killed, the file is quarantined, the registry persistence has been removed. When we say that, then we remediate that individual indicator. So if you have 7 or 8 indicators and we take care of 3 of them, then 3 of them will now become remediated. If all of the indicators on that endpoint have been remediated, then the overall device score becomes a 1 or remediated also. And that's very important from a lifecycle point of view. As we syslog out that a machine gets infected, HawkEye G takes action, and then the machine is remediated through our processes. You don't have to re-image it. We just remediate through our countermeasures. Then that machine has a score of 1. If that machine gets reinfected again, and then we clean it up, and it gets infected again, and we clean it up, now you have a life cycle. Now you see that an endpoint is infected, clean, infected, clean. So from security ops point of view, that's an interesting report. You know, that's an interesting alert that you can create based on the data that we're generating. Why is this machine getting reinfected? Maybe the end users is engaging in bad internet hygiene. Maybe they're clicking on things in email, or they're going to bad websites. Or maybe that user is being targeted. You know, they're the CFO. You know, they're the head of your legal department. You're a network administrator. Maybe someone is targeting that user, infect them, HawkEye G cleans up. The threat actor realizes that their exploit never landed or implanted, so they target you again. They target you again. So that is additional security intelligence that we can generate because we record the full threat management lifecycle on that. So if you come in and you can see the lifecycle of logging out as things happen. And in this case here, a registry change increases the device score to a score of medium. A file create changes it to a score of 8. Process executing changes it to a score of 10, right? And you can see how that increases the score. So once again, it's not a point in time. We have a time series view, a lifecycle view of this endpoint and malware activity with a threat actor. HawkEye G always detects, uses automation to always detects, always continuously recalculates its threat analytics score, and always recommends the next best action based on that indicator. In this example here, there's no policy defined. So the system detected, calculated a threat score, recommended an action, but no policy. So this will be the normal case if you don't have automation. So I am looking at Splunk, I'm looking at my QRadar, I'm looking at Logarithm or ArcSight, I see this, well, here's a score of 10, let me do something. You can quickly click on the source account, you can pivot into HawkEye G, here's the system, here's the 2 processes, here's the quarantine files, I can do verification to verify that it's truly bad through our triple confirmation, I can execute it manually and come back and you can see that the execution is success. So even if you don't use full automation policies, we reduce the detection, verification, and response time for even a human point of view down to seconds. I click yes, yes, yes. It does manual action. It logs who I am. And then the overall device score. The overall device score has been remediated because all of the individual indicators have been cleaned up. So even in a large-scale environment where you're looking at and responding to dozens or hundreds of these per day, we take all that 30 minutes of work, verification, look at all these screens, down into 7 seconds, very easy to look, verify, execute, done, and move on. But at the end of the day, the only way to keep up with the bad guys, they're using automation. They're using botnets. They're using exploit kits to infect and reinfect and target your organization. The only way to keep up is with automation. And we give you those control. We give you those policy-based automation controls to respond based on your environment. So on the left-hand side, we have this concept of overall cyber condition. I think the screenshot is probably a little fuzzy, but I had the text on here. We have cyber condition. You can set a policy at a certain cyber condition. If I'm under sustained attack, then maybe my policy is to do more automation. If I have a change management window, or we're updating, a version of Microsoft Office, or we're deploying a big ERP application, maybe I change the cyber condition and then do less or no automation during that change management window. So we give the control to the security team to align to how your IT organization is deploying new software and impacting change management. In addition to CyberCon level, we define a minimum threat score. Only take action if it's an 8, 9, or 10. Only take action if it's a 5 or higher. So we give you those two levers. You define what action. Do you want to allow it? Or you can deny it. You can create a policy to deny a certain action, and then all the countermeasures that you can perform for that policy. I create the policy, and I assign it to which users or machines or groups. So HawkEye G synchronizes with your Active Directory, and you can very easily map a policy toward a set of users, a policy for a set of machines, a policy for a group, and that's where all that automation comes in. So automation for detection, automation through triple confirmation of the infection and the activity, and then automation through policy management. The automation also is for bulk actions from a human point of view. Machine guided, I want to look at infection spread. I see this indicator on 20 machines. I want to remediate 20 machines at one time. That's that automated process programmatically to take care of those machines with our real-time endpoint agent. So if you already have network devices, if you already have Checkpoint or Cisco or SourceFire, you don't have to think that our network sensor competes with those. In some cases, customers don't deploy the network sensor because it's important that we fit into your security ecosystem. That's where you get the benefit from it. So if you already have devices like Checkpoint or Cisco or SourceFire, we confirm those by pushing what HawkEye G sees on the real-time endpoint. We push it into your SIEM, and you can use your SIEM to correlate our HawkEye G endpoint indicators with your network indicators. So out of the box, deploy host sensors, push syslog into your SIEM. You can see what's happening on the endpoint that the network devices saw or actually missed. If you do have Palo Alto Firewall, if you do have Palo Alto WildFire or FireEye NX, we directly integrate with those technologies. You configure those to push your threat alerts to HawkEye G. HawkEye G takes it, creates threat scores, overall incident scores, confirms if the endpoint has been infected. If it is, it raises it. If it's not, then it lowers it. And we actually have reference architecture and customer references around these deployments in production. And then ultimately, we complement your network devices. Network devices is a very easy way to get visibility. I buy a box, I plug it in a spam port, I get visibility. At the end of the day, you need to actually confirm what's happening on the endpoint and then remove that threat before compromise or breach. And that's where the HawkEye G gives threat removal on your endpoint using automated or manual responses based on our threat scoring and our active countermeasures. So very complementary. And then the last slide, I wanted to leave some time to give questions at the end, or for us to finish a bit early so you can go off into your next meeting or fight the next fire that you guys are working on. We love to do a product demo, right? We love to do a product demo with you on a live environment with live malware, with Palo Alto and WildFire coming in. We love to show that. You can come to our website, hexiscyber.com. You can click the Click Us or the Request a Demo link. And if you request a demo, we'll give you a live product tour walkthrough. We'll talk about all the incident and threat scoring. We'll show you very easy how you can do one click to confirm and verify malware. Our goal for automation is to give you triple confirmation so you're confident. We'll show you how to do machine-guided actions in one click. We'll show you how you can set up policy management to do automated removal. And then I talked about those malware hunting and ad hoc investigation use cases. You can actually use the real-time baselines that we build up for every endpoint, whether it's online or offline, and do malware hunting. or do ad hoc investigations, or you learned about Venom or Carbonac or some other threat, you can actually take those, put it into the tool and say, does any endpoint that I have in my environment, 100 endpoints, 100,000 endpoints, does it have these indicators? And you can very easily see that, whether the host is online or offline. So that's what we'll do through a product demo. We'd love to have you guys contact us. And if there's some questions, we can take those now in the next few minutes.
Okay, thank you so much. I'll jump into the Q&A portion now. We have a few that have come in. One of the questions is, can you give us a feel for the latency created while deploying inline?
Yeah, so great question. So what we've done for our network sensor is we've over-engineered our network sensor. So frankly, the cost of hardware, the cost of processing power and memory is very, very cheap. So we have metrics in very complicated network testing, high protocols, UDP, TCP, and we're getting less than 1 millisecond induced latency at 10 gig line rate bidirectional. Very fast system. We have a lot of extra hardware to layer on extra services as we launch those, but very, very low induced latency for UDP sessions, for SIP sessions, for video streaming, for TCP, very, very low reduced latency. And we actually have a technical application note that talks about the performance metrics for our network sensor.
Okay, thanks. The next question is, if you use a system to monitor only, can you send tickets to systems like Remedy even in the cloud?
Yes, that's right. So we do that through our syslog capability. So we don't have direct connectivity with Remedy, but our syslog gives you that rich information. What endpoint has it detected, what it detected on the endpoint, and overall score. And we can send it out via syslog, and that's something that Remedy can bring in and parse, regardless as long as the syslog connectivity does there. And the tickets is very important, because if you create a ticket automatically using what we've seen on the endpoint, we also have the ability to say this is no longer existing on the endpoint with our auto remediation capability. Then when that comes into Remedy, you can say, well, I can attach this to the first ticket, and I don't need to take care of it because the system took care of it by itself. So that's how we integrate using that syslog output.
Got it. And we have a question with implementing this with other solutions. Someone said, can they rely or still rely on semantic to do sandboxing technologies?
Yeah, so you still can, right? What we really built HawkEye G for is to augment and complement your existing technology solutions. People call it defense in depth. We really call it, broad picture and defender's advantage. So if you already have semantic and you're pleased with it, and it's giving you sandboxing, it's giving you some other stuff, that's fantastic. Now, from the AV point of view, all AV is having challenges, but you can still use us to actually detect the things that semantic misses, use our host heuristics for zero-day detection, and use our real-time baseline for indicators, ad hoc investigation, and malware hunting.
Got it. And a slightly different question, but if I don't have Palo Alto or FireEye, can I still use HawkEye G?
Yes, certainly. You certainly can. The reason why we integrated Palo Alto and FireEye is because our first customers asked us to. They asked us to solve the network ghost alert problem. These are the technologies you certainly can. If you have Checkpoint or you have Cisco or you have Fortinet and they're doing some things, HawkEye G can send all of those indicators and incidents via syslog into your SIEM, bring in your Checkpoint stuff into the SIEM, and then you can see on an endpoint basis in your SIEM if truly the checkpoint or the source fire or whatever network technology alert is validated by what we found on the endpoint. So if we don't have Palo Alto or Wildfire, we can certainly support those by pushing our indicators into your SIEM for correlation with those network devices. Okay,
got it. Another question was, how much automation do people start off with?
Yeah, so that's a great question, and it varies really depending on the size of the organization and how they normally roll out technology. We have set of customers that actually, once they deployed, they realized how infected they were. They turned on automation the first day to clean up their environment. Now their environment is clean. They turned off automation, and they're reviewing each one's one by one. We have other customers that started with machine-guided, then turned on automation for a certain class of users, then turned on automation for certain locations, and now they're in fully automated mode. Now, they're in fully automated mode at scores 8, 9, and 10, which is our triple confirmation, but that cleans up all commodity malware, all the things that AV has missed, all of the actively communicating malware. We clean it up through automation, and we let them review only that thin sliver of things that are remaining. So very flexible to line up on how you normally would roll this out.
Got it. And we had another question that just came in. Do you guys also work with NAC systems to put systems that cannot be remediated into a VLAN environment to isolate them?
Yeah, so great question, right? So our endpoint runs on Windows, but our network sensor can detect outbound command and control second stage download from any device, right? That's agnostic. So whether it's a Mac, whether it's an HPUX, whether it's an effective print server, our network sensor can detect that. If it's an inline mode, it can block it, and we can then syslog out into your system. So if you have a NAC technology like Forescout or Bradford Networks or Cisco NAC, that information that you get from the output from our network sensor, this machine isn't infected, and you can use your NAC technology to quarantine off that endpoint. Yep.
Got it. And I think you've answered this in part, but this is specific to investigation tools. The person said they're considering an investigation tool right now. Can they do that with HawkEye G?
Yeah, so that's something which we should talk about, right? Because there may be areas of overlap that we can do today with the investigation tool that you're considering, but then we get all the detection, all the verification, all the automated removal from the HawkEye G platform. And, I run product management, so it's very easy for me to talk about the roadmap. But, we have a very dedicated team of developers. We're issuing one major release every year, 2 minor releases every year. We are innovating very, very quickly. So those are some things I'd love to talk to you about when it comes on where our investigation capabilities can meet your needs and then where we're going so we can be that vendor of choice for your environment.
Great. Got it. Well, we are coming to a close now, but I do want to extend a big thank you to you, Chris, for your insight today. Great presentation. Of course, thank you to all of our listeners today for tuning in. This webcast will be available on demand beginning tomorrow on the SC Magazine website, so please join us next time.